Okay, last bit of converting points and equations, I guess, until we get to complex numbers. So this section, we're changing each polar equation to an equation in rectangular form. This is definitely the trickier way to go. We're still going to be using all of the things in our equation sheet. X is r cosine theta, y is r sine theta, and r squared is x squared plus y squared. So as you can see, and we don't really want to put a square root into our problem if we can help it. As you can see on this first problem, r equals 5. That is a nice equation in polar coordinates, and it's going to be not so nice when we put it into rectangular. So to convert this one, the first thing I'm going to do is square both sides. That is legal because I'm doing the same operation to both sides of my equation. That means I have r squared equals 25. And I did that because by squaring both sides, then I have a nice conversion where I don't have to use a square root. R squared is the same as x squared plus y squared. And you're in polar coordinates. I'm sorry, you're in rectangular coordinates from polar, and you can be done. So you can see how much simpler the equation for a circle is in polar coordinates than it is in rectangular. That's why we talk about polar coordinates. It is a nice system to use when you're trying to do some of these shapes that are not functional. This next problem, remember from when we were working with our points, r cosine theta is the same as x, and r sine theta is the same as y, so that would be 3 times y, and that's all equal to 6. That's a nice equation of a line. You do not have to solve for y there. That is a fine equation of a line. It's actually in standard form. 1x plus 3y equals 6. All right, last problem here, last conversion. A little more work to do with this one. So I see r squared, I see r sine of theta, and r cosine of theta. So I'm going to do those conversions first and then see what we've got. So r squared is the same as x squared plus y squared. And for r sine of theta, remember r sine of theta is the same as y. And r cosine of theta is the same as x. I'm going to bring that 8 down to x. You may recognize that this is an equation of a circle, but without doing a little more work to it, we can't tell what the center is or what the radius is. So I'm going to reorder so that I have my x's together and my y's together, and then I'm going to complete the square so that I can tell what the center of my circle is and what the radius is. Because otherwise, putting this in rectangular form doesn't really tell us anything if we can't tell what the center of the circle is and what the radius is. So again, I'm going to do x squared plus 4y. I'm sorry. How about actually putting our x's next to each other? X squared minus 8x. And when we complete the square, when you were taught that in Algebra 2 or Algebra 1, we add a box there. Y squared plus 4y. We're going to add a box there. I'm running out of room here. Steal some room for front seat here. On the other side of our equation, we still have that 5. But remember, when we're completing the square, we still have to follow the rules of equation. So whatever we do to one side of the equation, we have to do to the other. We added a box for completing our square with our x, and we're going to add a box for completing our square with our y. And now we can fill in those little boxes. So our rule for what we put in each box is b divided by 2 squared. So here for this first box, my b is -8. So -8 divided by 2 is -4. What goes in the box is -4 squared. And whatever I do to one side of the equation, I have to do to the other. Same thing with my y's. My b is positive 4 here. So 4 divided by 2 is 2. So 2 squared is going to go into each of the y boxes. And now, if you write it out like that, here's the nice thing. In order to factor x squared minus 8x plus negative 4 squared, what you do is just do x minus 4 quantity squared. You take one of the x's and one of the negative 4's, and you're done. Same thing with your y's. If you leave it in this squared form, you don't have to think about how to factor it. You can just bring one of your y's, one of your positive 2's, and you're in factored form. On the other side of the equation, you can just put that mess in your calculator as it is. And all of that together is 25. So the center of this circle would be at 4, negative 2, and the radius would be the square root of 25, which is 5. That tells us a lot more than this x squared, y squared gobbledygook that we started with. All right, now we're going to do some calculator work and writing equations of polar coordinate shapes.